Solve the rational inequality and then write the solution set in interval notation. We have x divided by x plus 2, which is greater than or equal to 1 over x plus 2. So let's take a look at that. So before we find our interval boundaries, we need to take a look at this inequality. We want to make sure that we have 0 on the right side. So in order to do that, we need to subtract this term to this side of the equation. So for step 2, we should get 8 over x plus 2 minus 1 over x plus 2, and that's going to be greater than or equal to 0. Well, we can see that it already has a common denominator of x plus 2. So we have x plus 2, and then in the numerator we have 8 minus 1. Well, 8 minus 1 is going to give us 7. So therefore this is going to be 7 over x plus 2, and that's greater than or equal to 0. Now to find the interval boundaries, we're going to look at the rational inequality and turn it into an equation. The numerator does not contain an x, so we're not going to be using a numerator to determine the interval boundary, but the denominator does have a variable. So we have x plus 2 equals 0, and therefore x is going to equal negative 2. Now keep in mind that negative 2 is a restricted value because that would make the denominator 0. So we need to make sure that we know that that's a restricted value. Okay, so now before we begin the testing points, we need to draw our number line with our interval boundary. So we can see here that we have negative 2 as our interval boundary. So that means we have interval 1 and then interval 2. It's going from negative infinity to positive infinity. We go from negative infinity to negative 2 with a parenthesis, and then we have negative 2 to positive infinity. So down here in the interval, it's going to go from negative infinity to negative 2 with a parenthesis, and then down here is parenthesis negative 2 and then positive infinity. Okay, and so now we need to find our testing points. So we're going to use step number 4 as our rational inequality, which is 7 over x plus 2 greater than or equal to 0. So for interval 1, we're going to pick a number to the left of negative 2, which can be negative 3. So x is going to equal negative 3. So it's going to be 7 over negative 3 plus 2. We want to determine if that's greater than or equal to 0. Well, negative 3 plus 2 is negative 1. 7 divided by negative 1 is negative 7. And so is negative 7 greater than or equal to 0? Well, the answer is false. So we know it's false for region number 1. So here, this would be false. Okay, let's take a look at region number 2. We're going to pick x equals 0 and then plug it into the inequality. So it's 7 over 0 plus 2. We want to see if that's greater than or equal to 0. Well, that becomes 7 over 2. And that is a positive fraction, which is greater than 0. So we know it's going to be true for interval number 2. So it's true here. So let's just go ahead and put these answers in first so we can see what the interval looks like. So here we know that the interval goes from parentheses negative infinity, comma, negative 2. And then this one goes from negative 2 to positive infinity. We determined that this one was false, and we said that this one was true. Let's just check. Let's check our answer, and there's our result. Now we need to determine what is the solution. So we need to be careful, again, because of the fact, that this is a greater than or equal to. So that means we're not going to use a bracket for negative 2, so it's going to be parenthesis, negative 2, comma, infinity as our our solution. So let's go ahead and put that in there. We have parenthesis -2, comma, infinity. With our parenthesis, let's check our answer, and there is our result.